Did you know you can increase your understanding of mathematics simply by changing your mindset? In this video, I'm going to outline some really important ways we're going to learn math this year. You can see in the little cartoon that I put, here's a little teaser, fixed thinking versus growth thinking. And mistakes allow thinking to happen. Carol Dweck wrote a book called Mindset, which used brain research to determine that there are two basic mindsets that we can get into, fixed and growth. And you can see here in this graphic some of the characteristics of each type of mindset. And these mindsets don't just apply to math. They could apply to sports. They could apply to playing an instrument or just about anything that you want to learn. And so you can see here that a lot of students fit, and I did too, fit into the fixed mindset. Making excuses, being afraid of challenges, refusing to learn from mistakes, thinking I was smart or dumb based on mistakes that I made in class, and basically not growing very much. And another thing I would add to this is that I learned very early on to do math by memorizing and not by understanding concepts. So when I read this book and I realized that this growth mindset is a way to train your mind to accept challenges and to keep working in determined effort, really would make a difference in just about any topic. Anyway, I highly recommend this book. It's called Mindset, and it's Carol Dweck. Another great pioneer in mathematics education, leading the revolution, is Joe Boaler. And Joe Boaler made a video that I'm going to want you to watch called How You Learn Math, with 4 key messages. And these are the messages that came from that video, but these are some of the things that we are going to incorporate in our class. You know, this was not the way I was taught math, and it was not the way I was taught to teach math. But I found fault with both of those methods, and I've been working over these years to find and develop a different way of thinking about math in my own life and also for my students. And so if you look at this, the one that's the biggest here is that everyone can learn math to the highest levels. Everyone to the highest levels. Mistakes are valuable. Questioning, hugely important, and asking good questions. We're going to do that a lot. Why, how, explain, why, explain why, how. Math is about learning, not performing. We're going to go to the boards in this class. We're going to be working problems all up at the board, and you're going to be able to look and see what other people are doing and what their thinking is, and you're going to be able to talk about it, and you're going to find that it's really kind of fun, and it's about creativity, making sense, and depth is more important than speed. Now, speed is a reality. We have timed ACT tests. We have timed AP Calculus tests. We have time to take a test. We have a class period to take a test. But I'm working on this to make speed less important. Just because you're a quick thinker doesn't mean that you understand things any better than someone who's a slower thinker. And we've got to dispel that myth. And then math is about making connections and communicating. And we're going to keep talking about these. I have them hanging around in my room, and I'm still working on them. I am still working on these as well. Like I said, I didn't start out believing this, but I've seen it, and it truly makes a difference. Have you ever noticed that mathematical notation is like another language? The Egyptian hieroglyphics, right? Symbols, and they all have meaning. And it's everywhere. I liked this part right here where somebody just kind of took an equation and then put a refrain next to it. It is what it is. I don't understand this one. I don't have regrets. Maybe you've got that one. And then this one, just saying. All right? And then some of this, right? I just went on Google and I found this one is more like an Algebra 2 or pre-calc level, but these are not. But look at them. I mean, I don't even know what they mean. All those symbols, and they all have meaning, just like a language. You know, if you wanted to learn a language like French or Latin or Chinese, It requires practice. You have to learn the symbols. You have to learn what the words mean and the order of the words and how the sentences are constructed. It all requires a lot of effort, speaking it and hearing it and thinking about it. Well, math is no different. So to understand math, you've got to learn the language. You've got to practice the language. You've got to make sense of the language. The knowledge builds on past knowledge. So once you learn how this word or symbol is used, then you can use it later in a new. And this all takes time and practice. So if you want to understand something and you want to learn something, you have to spend time in it. And this is hugely important. Another important concept that I'm going to emphasize over and over and over is that the answer to a problem is the least important part of the problem. Some of you have been in classes, especially math classes, where you follow a procedure, you get to the bottom, you do a circle, then you do another one like it, and another one like it, and you circle the answer, and you circle the answer, and you circle the answer, and you have no idea if it's right. You have no idea how you got it. You just keep doing the same procedure over and over, and then you reach a problem that doesn't go by that procedure, and you don't know what to do. Well, to me, you need a better way of doing problems. And so what I want you to begin to understand is that I'm not going to give you 10,000 problems to work. I'm going to give you fewer problems, but I want you to work them in depth. I want you to understand the problem and the concept behind it. I'm handpicking these problems so that you can get at the concept, and it gives you enough time to practice. But just like it may only take you 2 problems and you've got the concept, it may take someone else 10. You may have got it by watching a video fast forwarding. You may watch a video in a flipped classroom and need to watch it a couple of times. You do what you need to do to learn the problem. And so we're going to work on this now, especially in calculus. They call this thing justify your answer. Justify your answer. Well, what does that mean? Well, to justify means you're going to explain your answer with common evidence. How do you know that's the center of the circle? How do you know that if you fold it in half, you've divided it into 2 pieces? How do you know that that x plus 3 equals 5? How do you get to the next step? How do you know you can subtract 3 to the other side? You know, and so we're going to work on these things with some simple concepts, but we are going to work at explaining our answer. And this is a skill that you probably don't know a lot about, so we're going to keep practicing it. So here are some questions. What math did I use to arrive? Can I explain how I got? Does the answer make sense? Why is this answer correct? Can I explain what I did to get the answer to someone else? Okay, so justifying our answer is going to be really important. So here's an example, and I put a little trig example. This is really trig from geometry. So it's not from, trig class. Everybody should be able to do this problem. Okay, so here's a fairly simple problem. Justify your answer, write out what you know about the question, give evidence showing your work, and state your final answer in a concluding statement. Okay, now we're going to do this informally, and I'm going to give you an example. All right, so we're going to unpack this problem. First we read it. Find angle A to the nearest minute, 0 degrees. The measure of angle A is between, so we're looking at notation. Okay, and I'm glossing over this because I'm really just reading it. And then you've got this notation. You've got cosine A equals this decimal. Okay, so what we're going to do is unpack. What are we trying to find? Angle A. So that's what we're after. We're going to write the measure of angle A to the nearest minute. Okay, nearest minute. So that means that we're going to be using degrees, minutes, and seconds. Okay, degrees is what we're after, not radians. Okay, and then this symbol, this notation, the angle needs to be between 0 and 180 degrees. Okay, so that's my criteria. I'm finding angle A to the nearest minute, and then it has to be between 0 and 180 degrees. Okay, so I'm looking here, my trig function. This is trig function. They've told me that A is an angle. So this is the cosine of an angle, and I know that trig functions are just ratios. Now, that's not a ratio. Typically can be written as a fraction. This one's just divide it out, right? Decimal is a ratio. So, I'm sorry, that's kind of messy. Okay, so in order to do this, right, we want to get the angle equal to something. Well, to undo a trig function, we take the inverse of it. So the angle is going to be equal to the inverse cosine of a ratio. Okay? Okay, so I've included a screenshot of 3 possibilities for accomplishing this problem on my calculator. Okay? In the first one, I just put the ratio in. I took the cosine of the ratio and I got 0.96 da 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 da. And if I'm thinking about degrees, that seems kind of small. It's less than 1, right? All right, so then I decided to do cosine inverse of 0.2504 and got 1.31111, right? And I thought, that doesn't really make sense, that answer. All right, so A would be 1.31777. All right, so justifying your answer and also using these other concepts, I'm going to be asking questions. Does this answer make sense? Well, no, it's too small. 1 degree? I mean, that doesn't seem right at all. So what if I put in, 0.9999? Did the inverse cosine of 9999, right? And remember, to get this one right here, you would hit the second button and then cosine. So you're taking the inverse cosine of a ratio to get an angle. So the procedure was correct, but the answer's not. Some of you may have guessed this is the correct answer. How on earth did I get from that to that? Well, I realized that my calculator was in radian mode, and I needed it to be in degrees. If I was just keying in on a procedure, second cosine, blah, 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 write it down, da, 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 follow the procedure, and did not make sense of my answer, I would get it wrong. Okay? It didn't make sense. It was too small. 75.49, da, 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 that makes sense. So this is the one I'm going to use, right? I changed my mode to degrees, somewhere between those 2 arrows in there, and I'm going to use that problem. All right, so now I have to know, how on earth do I get from a decimal answer to a degrees, minutes, seconds? Well, degrees, right, has a component. Minute, how many minutes? 60. And seconds, how many seconds? Can't spell seconds and talk. In a minute. In a minute, there's just 60, right? But in a degree, there would be 60 times 60, which is 3,600. Okay, so let's convert this to an answer. So I have 75 degrees plus the decimal equivalent, 4988. I'll probably put the whole thing in my calculator, 1662. And multiply that by 60. That gives me minutes. Okay? And that gives me, I've done this ahead of time. Let's see if I can find my answer. Is 29 and change. So 29 minutes plus 0.928 times, now here's my question. Does it make sense to multiply this times 3,600? Because this is a partial, this part right here is a partial minute. So how do I go from minutes to seconds? Times 60. And so that's going to give me, when I round it, 56 seconds. So my answer, so angle A, I check, is it between 0 and 180? Yep. Angle A is 75 degrees, 29 minutes, 56 seconds. Right? If I just write an answer and circle it, I have what I have written here, a bald answer. This entire screen is my answer to the problem. It is my answer to the problem, and I'm making sense of it as I go along. There are parts of it I might not know how to do, and I might have to ask a question. I might still not understand after looking at this, and I might have to ask a question. That's what's expected here. If you don't understand, ask a question, and then keep after it until you do. So this is a summary slide. In this class, we value a growth mindset. Math is a language that can be learned. The answer is the least important part of the problem. Mistakes are valuable. Questions are important. With the correct strategy and effort, you can learn math to the highest levels. I know you can do this.